And then I will give you the where we at? Where's Nathan at? There we go.
Welcome for those that just came in.
All right, Nathan, it's all on you, and we're here following you guys. We have 45 minutes, but sometimes they like to be nice to me and give me a couple extra minutes. So
Yeah, it's cool. We'll make it happen.
All right.
All right. Hey everyone. First off, I'm looking here. It looks like you made me host.
Yes, sir.
Okay.
Yeah, you're host now.
Okay, cool. That's weird. It's not letting me make Joram, it's not letting me make you co-host. But what we'll do is just when we get to the part of the section that you're going to take over, I'll just throw full host to you.
I think that's more of a pro tool, and I don't know if they let you do it on the free.
No worries. I have the. Anyways, I don't want to burn minutes on that, so it's cool. It's all good. We'll make it work. Welcome everyone. My name's Nathan. And today we're also joined by Joram. We're lucky enough to have him here with us. I thought maybe we could take a few minutes, just real quick, and Joram and I could kind of talk about who we are, what our backgrounds are, and why you should listen to us about JavaScript. So I'm Nathan. I work at Lambda School in more of a student capacity, though. I'd say I'm like halfway in between being a staff member and being a student, because I'm a full student myself. And I just got hired, which is really cool. If you were here early, you might have heard me say that that Friday is my last day section lead, and I'm currently in the computer science part of the curriculum at Lambda School.
Okay. Is that it for you, Nathan?
Yeah, that's it for me, I think.
Okay. All right.
Just to save time.
Hey everybody, I'm Joram Clervius. I think I know a couple of you guys from Twitter, but I also graduated from Lambda School a while back, almost 2 years ago. Currently, right now, I'm a senior engineer at Nexient here in Michigan. I lead a team of about 10 software engineers. So the reason I think you should listen to me for JavaScript is because it's running. I also, if anybody here is towards the end of, I guess, their program or at least looking for a job in Michigan, I'm also very well connected and also work with the team of people at Nexient who is recruiting, and I also interview people there as well. So that's that for me.
Awesome. Yeah, he's serious about the job stuff. It's a pretty cool team that he has going over at Nexient. So awesome. Okay, so we're going to go ahead and jump straight in. And let me share my screen. Okay, so what we've done, and you're welcome to take notes and follow along with us as we do some stuff today. Just a heads up that we will be providing all of you with the link to this Codesandbox. We're using a service called Codesandbox today. A lot of you have used like CodePen and things like that. Codesandbox, don't be intimidated by it. Literally the only reason we're using it is because we can live code with each other as we're showing you stuff, and use the exact same Codesandbox instance to be able to code together. So what we're going to do today is we're actually going to start off by talking a little bit about what callbacks and higher order functions are. Many of you are in Lambda School that are here and know that there was recently a JavaScript assessment. These played a big role in that. Some of the rest of you are still applying to Lambda School. And this will be a big part of both what you learn in the pre-course, if you haven't already covered it, as well as things that you will learn in the actual course content once you get to the vanilla JavaScript section. So what are higher order functions and callbacks? I'm going to go ahead and pull down some code here. So this is a higher order function. I have named it higher order func right here just to make it easier for everyone to know and to keep track of. And here I have two different arguments being passed in. They actually, if you've never seen this before, this equals, and then an empty array, and then CB, which stands for callback, by the way, which is what we're talking about. CB equals, and then an invocation. This is an arrow function, which we'll get in more into what arrow functions are. If you haven't used them a lot, we'll talk about that a little bit more towards the end of the presentation. But what the important thing here for each of these arguments, array and callback, with these equal signs, is it's defining a default value, which is something valuable to start doing in your functions. Really, it just means that when you run the function, if you forgot to pass in one of these arguments when you actually invoke the function, or let's say you are further along in the course at Lambda and you are sending it data from like a server or something, and some of that data didn't come through successfully, it just has a default value that it will assign to it if it doesn't get any when you call it. And then there's something interesting going on inside of this function. You notice we're using CB here and then passing in the array, this word array, this argument. So what's going on here? A higher order function is really just a fancy name for a function that accepts another function as an argument, as a parameter, sorry. And it takes in another function, and then somewhere inside of the body of the function, it actually uses that argument. It will invoke it. It will, in this case, pass in that array into this. So why does that matter? Well, we're going to start off with some examples of this and slowly build up to why that matters. In particular, callbacks and higher order functions are used. Anytime you've used an array method, if you've ever written an array method before in JavaScript, you have unknowingly used a higher order function and a callback function. And we'll get to that in a little bit. So the first thing that I want to do is I actually want to go ahead and I want to take this function right here. Look, Cassandra, I see you muted yourself. I'm going to go ahead and mute you if that's okay, just for everyone to know if you wouldn't mind keeping everything muted since we are recording. All right, so I've pasted in another function here, function 2. So watch this. What I'm going to do is I'm going to console log the higher order func. Then I'm going to pass in, right now, I know up here we defined the first parameter as array, but what's cool about this higher order function is depending on what I'm passing in as my callback function, this callback function is expecting a number. I can actually switch up what this higher order function is doing. So I'm going to go ahead and pass in the number 10, and then I'm going to send in add to. I'm going to save it, and look at that. Notice that 12 was logged on my console out here. Whoa, so what the heck is going on here? Okay, what is happening is I am invoking this higher order function, and I am passing in the number 10, and it overwrites this, right? It overwrites this default parameter here. We could just as easily call this, and it might be more self-explanatory. Instead of array, we could call that value, something like that, and it would still run just fine. So even though the default parameter is an empty array, we have overwritten it with a 10 when we passed it in. So imagine that gets changed to 10, right? And then I have passed in add to into here. So what's happening is add to, this function, gets passed in for the callback. It overwrites this return null value, and it ends up, imagine that this effectively got placed right here, right there, okay? It's gonna throw crazy errors here, but imagine that's basically what's happening, is this ended up being placed there and invoked inside of the function with the value of 10 here that I passed in. And the value of 10 gets passed into the callback here, which is really getting passed into add to. And inside of add to, what's it doing? Well, it's doing exactly what it's named for. It is adding 2 to whatever number I pass in. So I could put in 20 and it would log out as 22. I could put in 2 and it would add 2 to it and it would be 4. Does that make sense to everyone so far? What's going on there? Okay, cool. So the other thing that I'm going to do is I'm actually going to pull in a function called test item. So what is this doing? Okay, so test item inside of the body of this function, this also takes in a number. It has a default value of 0, but it takes in a number, and it has an operator, the modulo operator, and modulo by 2, and then a triple equals 0. So what's going on here? So what this test item function is doing, and if you've never used the modulo operator, this is what it does. The modulo operator divides whatever this number is. So in a way, it's sort of like the division operator. But with the modulo operator, what happens is it returns the remainder of the division. Okay, so let's say you were to divide 5 by 2. You're going to have a remainder, right? That's not going to be it's not going to be a clean division with 0. You're not going to be able to cleanly divide 2 into 5, right? You're going to have a remainder left over, and that remainder would be 1. So what's going to happen here is when I test an item, let's say I was to pass 4 in. If I was to pass 4 in here into this function, and it's going to just ignore this massive screen of death over here. If I was to pass 4 in to test item, and this return num, that would become 4. 4 modulo by 2. 2 can divide cleanly into 4 as a whole number, and it does not have a remainder. So essentially what would happen is that since there is no remainder, it would be true that this statement would evaluate to 0, and 0 does equal 0. And so this whole statement would evaluate to the Boolean true, which is really what we're getting at here. With test item, we are going to test each number as we send it in and test whether or not, essentially, that item is even, since we're dividing it by 2. So that's what test item does. We're going to go ahead and use our same higher order function here. Notice how we're starting to reuse this line of code, and we're able to start composing things together. That's a key ability of higher order functions and callbacks is composability, to compose different pieces of code together. So I'm actually just going to go ahead and swap out add to for test item. I'm going to save, and look at that. It comes back true, just like we said, because we're passing in the number 2. That is even. It is cleanly divided by the number 2, and it is, in fact, an even number. If I was to pass in the number 3, that would then become false. So notice now that we have been able to use our higher order function, and we even reused the same number of 2, but the entire functionality of our little application, our little lines of code here, changed when we just changed the callback function that we passed into it. That's pretty crazy, right? So one last thing before we go any further. Let's see. We've been going for 17 minutes. Okay. One last thing I want to do really quick is I want to paste this in. I also want to paste in this right here. And what I'm going to do is I'm going to call this total nums. Okay, so this does expect an array coming in. There's a default empty array, but what it's going to do is it's going to define an empty a variable total, assign the value of 0, and then total up, adding to total up everything, every single number in the array. So what I'm going to do is first, I'm going to make an array, and then finally, I'm going to pass in total nums. And then save. And look at that. Now, again, completely reusing my higher order function, I have changed what I am passing in, and I've gotten a completely new answer. I've passed in this array of numbers, and total nums, my callback here, added all of them up and then gave me back a new answer. So why is that super relevant? Well, first of all, just FYI, higher order functions, callback functions, this kind of stuff gets asked on interviews. So heads up on that kind of stuff. This might be something that you would want to put a little bit of practice into. But on top of that, you're going to notice this pattern of using a higher order function and then passing some new values, a new callback function into it immediately here as we get into the for each array method. So what I'm going to do first is I'm actually going to define Above this, I'm going to define a nums array, a num array. We are going to use this several times throughout the presentation today, so just keep in mind this runs from 1 all the way up until 10. So the first thing that we're going to do is I'm actually going to copy over this. And I'm going to change that to the nums array, and boom, we have a bunch of numbers printed to the screen. So what's happening with this? And what is a for each? Okay, many of you probably have already written a lot of JavaScript where you used a for loop. Does this look familiar as I'm typing it up? Where you have like, you know, I is less than 10, and then like I plus plus, and then you do something inside of the for loop, right? This probably looks familiar if you've written or done much JavaScript whatsoever. A for each is very analogous to a for loop. In fact, that's basically what it's doing. It's going to loop over, in this case, all of these numbers in the nums array. It's going to loop over every single one of these, and for each one of these numbers, do something. Notice that for each is taking in a function, which means, based on our definition before, for each is a higher order function that is taking in a callback function. What we could do, we really wanted to, so we could just do that, and then we could say print num. Does this look more familiar to what we had done up here? When we had our higher order function, and then we passed in an array, and we passed in one of these functions, we essentially were doing exactly what we're doing here with our for each. We were taking a higher order function, and we were passing in a callback function into it. In this case, the body of this function is just console logging every single number as we iterate over it. However, we can do more. We can do better. So let's do this. Let's bring in a new variable. I'm going to call this one updated array. And let's go ahead and do something for each number in this nums array. We're going to do something, and I want to go ahead and push to this updated array. So what I'm going to do is I'm going to say updated array dot push. If you haven't used this before, what the dot push essentially does is I'm going to be tacking on to the end as we grow this array out something, whatever I want to push to it. So I'm going to go ahead and push to this each num as it comes in, and I'm going to add 10 to it. So I'm going to go ahead and save that. Now notice it's no longer printing anything out to the screen. I am not currently console logging the updated array at the end, and I got rid of the console log down here. So I'm going to console log updated array, and boom, look at that. Instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we have 11, 12, because we have added for every single item 10, and then pushed it to this new array. Does that make sense to everyone? How a for each is not only a higher order function taking in a new callback function that you write and that you get to decide whatever this callback function does, but on top of that, this is basically the same thing as writing out one of those big long for loops that you've done before. Does that make sense to everyone? Any questions about that? Okay. All right, let's see here. There's something else that I want to do, and that is I actually want to talk about the map array method, and then Joram can take over and lead you through some of the advanced array methods, some really cool stuff that we have prepared for you. So I'm actually going to switch it up a little bit with map, and I'm going to show you an array of strings. Let's go ahead and comment that out. So we're not console logging anything, we're keeping it clean. So here's our words array. Thing 1, thing 2, thing 3, right? Looks great. So this is what we're going to do. And this is something that I want to show you because it's the key difference. It is the key difference for the difference between for each and the difference for map. With for each, whatever you do with for each, whether it is changing the original array or it is pushing to a new array, you're not actually returning any data directly from for each. As in, if I was to console log this, because I am pushing to this array, we're not actually returning any data. For each does not return a new array. Now, what does that mean? I think the best way to demonstrate what returning a new array is actually to show you the map method, which does return a new array. So what we're going to do is we're going to call this new words array. So this is brand new variable, but what we're going to do is we're going to go ahead and map over for every single, and imagine in your mind that this is just like a for loop again. We are doing something, but we are going to modify each of these items, but instead of modifying them on this words array here, we are going to return a completely new array, and I'll talk about why that's important in a minute. So what I'm going to do is I'm going to say, for each one of these, we're going to do another function, and we're going to call it copy with dude. And we're going to pass in each word. So what we're going to do is we're actually going to return that word, and to it, we are going to add the word dude. And I'm actually going to throw like 3 exclamation marks in. Okay, so let's go ahead and console log this. And look at this. Thing 1 dude, thing 2 dude, thing 3 dude. But notice this. I'm not logging the words array here. In fact, right above it, all console.log our old array, words array. Look at that. Our old array is still here with the same exact data. But the difference is with map, since map, when you're done with whatever you're doing here, if you just return the values, map returns a brand new array and assigns that brand new array to new words array here. So map copies the existing values and does something to it and returns a brand new array, where for each does not. For each does not make a new array, which means if you directly change any data from the existing, in this case it was a numbers array, you are directly it's called mutating. It's changing essentially the old data. Now, why should you care? When I was first learning, I think my perspective was, well, why does that matter? You know, like I need to like do a function for a homework problem and then have it spit out the array anyways. Think about this. Let's say future you is making an application. And in that application, you have a massive array that displays out to the screen. This is a very hypothetical example. But let's say you have a massive array of data that's displaying out to the screen, and that, depending on what's in that array of data, it will change whether buttons are available on the screen or whether like whatever's available on the screen, you know, different stuff, okay? Let's say that this array is so massive though, and this is hypothetical, so massive that it would take you 5 to 10 seconds to loop over and change, okay? 5 to 10 seconds. Well, in your application, if you do something and it uses for each and it directly modifies that old array, in that 5 to 10 seconds, as it gradually changes items inside of that array, if that array controls the way things look on the screen, then over the course of 5 to 10 seconds, things could get a little wonky. Stuff could shift around. Things could start looking a little bit weird in that application because you are directly changing the existing array. Whereas if you do everything you need to do, and then only then at the end, you return a new array, and then boom, that's the new source of whatever for your application, then you're not going to have any risk of those changes. And in programming, those changes are called side effects. You do not want negative side effects. You can have positive side effects, things that you want to change in your application. But you don't want anything janky happening in your application. And so that's why right now, when we talk about the importance of how .map returns a new array, that's actually a really big deal. It may not matter when you're just mapping over an array of 5 strings, but trust me, it will matter a lot someday when you are actually writing an application. And so it's good to get in these habits now of knowing what array methods do what things, so you can know when to use them. Let's see. Okay, I'm going to go ahead and turn it over to Joram. Joram, I'm going to stop sharing, and let's see. I do have a few questions. Okay, awesome. Any questions about my section before we go into the second half about filter and stuff like that? Oh, it looks like we only have 10 minutes instead of 15.
Oh, I'm sorry, fellas. I had no clue.
Let's see. No, it's okay. It says we're on a paid plan. Okay. I don't know if we have time for questions.
Yeah,
That's fine. I can just go.
All right, sorry. Joram, I thought we had like another 15 to 20.
All right, man. Can you guys see my screen?
Yep.
All right, so let's just get started right where he left off. I want to actually add a little bit more to what he said, and it's a very, very important thing. One thing to help yourself remember exactly if you're changing the current array or if you're returning a new one is if you take a look at exactly what you're doing. So what we're doing here is, you guys can see what I'm doing, right? Yeah? Okay, good. So what we're doing here is we've already declared this array, nums array, and then we've decided, okay, we're going to take the same nums array and we're going to do something to it. Right there, that's an indication that we're going to do something to the existing array. We're going to mutate it. However, over here, we've decided to declare a brand new, variable, and then take the old nums array, go through each and every single thing inside of that, do something to it. But in the end, whatever we end up doing with this old nums array is going to get attached to this new variable. So that right there is a clear indication that you're returning a brand new array. You're doing something from the old array, doing something with each value in there, and you're returning a brand new one, and that new array is going to get attached to this variable that you declared. So the two new functions that I'm going to go over are filter and reduce. Those two, along with map, are brand new functions that came with ES6, and all three of these return a brand new something. So a brand new array for map and filter, and then depending on what your choice is for reduce, it returns whatever that thing is. So what I'm going to do is I'm going to bring in the filter method. So this is very, very, here we are, we're declaring filtered nums as a variable. And what we've done before is, of course, we've declared a variable called nums, but what I'm going to do is take the same array that we declared up here. And one thing that I want you guys to think about is the callback functions we were doing earlier, where we were saying, okay, you know what, we can pass one function into a higher order function, which is what's happening over here, what filter is. Before we got all the way down here, he talked a little bit about the test item function. What filter does, so let me just kind of describe filter a little bit. What filter does is it expects a function that you pass into it, and that function has to return a Boolean. A Boolean is something that's either true or false, because what it does in the end is it returns another array. So you take the array that you're initially coming and starting off with, and you're going to return a brand new one. It's going to go through every single item in that array, and it's going to run it through the function you pass in here. And if it returns true, if that function returns true, then it keeps that item in the new array. If that function returns false, then it removes that item, and then you end up with an array that's filtered out everything that returns false. The good thing for us is we already have something here that says, okay, you know what, let's test items. And we can run this test item function on every single value in here. So of course, some of these are odd and some of these are not. Some of these are even. So what we can do, just like we did a while ago, is we could take this nums_r.filter and pass it test item. Test item will run through every single thing inside of nums_r and keep only the ones that return true. So let me go ahead and show my console here. There we go. I'm gonna comment these out. We're gonna log filtered nums. As you can see, it's only keeping the ones that are even. Because it's running through this same function up here that's testing every single thing you pass to it to make sure that it only keeps in this brand new array only the ones that return true from this function. How much time do we have left? Do we have enough time to go over reduce?
Another thought I had was we could just start a new meeting.
Yeah, I can do it. I can start it
Get
up.
another 30 minutes.
Yeah.
All right. So let me just bring up the reduce function that we had a little bit earlier. and by a little bit earlier. So Nathan and I actually talked through this a little bit. So we've gone through what's happening here. This is going to be a little bit more complicated. And the reason that is reducing is usually used to take the array that you have and turn it into something else entirely, or just to run whatever your logic is that you want to do with it. So of course, one of the other types, data types that you have in JavaScript, in addition to arrays, are objects. In this case, I just want to explain what I have coded here, and then I can show you guys what gets returned at the end. So reduce is another higher order function that takes another function. This function that it takes initially starts off with 2 values, but it does have some more parameters. What I've declared here is accumulator and current. Accumulator is, so as you go through, what reduce does is as it goes through every single item in the array, so you can say, okay, you know what, let's start off with this array and reduce it. All reduce is saying is, okay, I'm going to pass you the first item, you do something to it. But whatever you've done to it, I'm going to keep what you've done to it, and then we're going to pass you the second item. So now you have what you've done to the first item stored in your accumulator right here, and then what you want to do with the current item, here's the current item. But when you first start, of course, your accumulated item could be nothing. And this is what this second argument is over here. So as you can see, I have a comma right after, I have a comma right after the main function here, and that's because you can declare something to start off with. So right here, I'm starting off with a brand new blank object, right? And so I'm saying is, okay, let's spread that blank object here. So once we start with the first thing, let's spread that blank object here, but then let's take the current one. So for example, over here, we're running through nums array. Let's spread the blank object. We're going to return that. So we start with 1. 1 becomes the current item, right? We're going to spread the blank object, and then 1 is over here attached as the property in our brand new object. So we're going to say 1 is attached as a property, and what's assigned to it is another object. And this object has 2 properties, even and doubled. Doubled is because we did have something called add2, right? There we go. So we do have a function here that adds 2. So we're going to run each item through both of these functions and attach the result of those functions inside of this object. So we're taking the first one. I'm just going to walk through it very slowly. The first one, so we're going to end up with an object. This is all reduce is doing. It declares an object that takes the first value from this array, and then it's going to run it through test item, which will determine whether or not 1 is even or odd. So right here, where we have even as a property, we're going to end up with false because it's not even. And then for add2, or is that the property of doubled? For the doubled part, it's going to run it through the add2 function. And then so, of course, what's add2 doubled, yeah, we named that differently, but please don't get too confused over that. For double, it's going to add 2 to it, so that's going to become 3. As soon as it's done with this, it's going to pass this whole object again as part of the accumulator, and then you end up with the next item in the array for your current. So with that, what we do with current in that case, we put 2 here, and we return yet another object for it. Is 2 even? The answer is yes. So then it runs through that function, you end up with true here. And then is 2, once you've added 2 to 2, double, it becomes 4. And so we end up doing this inside of the reduce function for every single item in this array. And so that's what I'm going to log for you down here. The good thing, so like we just said a while ago, right? Map, filter, and reduce all return a brand new thing, whatever that thing is. So the good thing about what we're doing here with reduce is that everything we've just done with this nums array is we've taken all those things and we've added them inside of this object, and we've stored everything, the whole result of this, inside of this one variable called transform. So then you can console log that, and you end up with this object that has every single item from in there, and you have whether or not 1 is even, you've got false, if double is 3. Of course, double, I know it says double, but it's just add 3. As a matter of fact, I can change that. I mean, add 2. So then that becomes the property here. So we've done that. So that whole array now becomes a huge object after you've gone through everything. There are other things you can do inside of reduce. Reduce happens to be one of the most complicated, but also one of the most useful methods that are attached to arrays in JavaScript. You can, in fact, test the item before you include it in this array or in this object to say, okay, I'm only going to include the ones in here that are even. But here's something else you could do. You can actually chain things in arrays. You could even do that before you get to here. So one thing you could do is you can filter. You can run that whole array through the filter before you even reduce it. because what you're doing here, keep in mind, we told you that this returns a brand new array. So we're taking that array after it's been filtered, and then we're reducing on it. So then we only end up with items that are even. Everything in here should be true, right? So that's one of the cool things you can do inside of reduce. You can do a whole lot of cool things, and this is yet one of them. And you can actually map things too. So let's say we want to map all these through add to before we even filter and then reduce to that. We can do that too. Whereas